So now we are going to see how to solve this problem of, here we have indicated as question number 25. Show that the height of a closed right circular cylinder of given surface, here we mean the total surface, and maximum volume is equal to diameter of the base. So now how we are going to do this, just shall see now. See, he says the surface is given, that means the surface area of the cylinder is fixed. So surface area is equal to, so surface area of the cylinder is, as you know, it is 2 pi r into h plus r. So it's a given value as per the question, so it's a constant. Let us have it as k. So with a given surface area, that means your surface area of the cylinder is a constant value. He wants us to show that the volume of the cylinder will be maximum if the height is equal to the diameter of the base. So what we need to show is to show volume is maximum if your height is equal to diameter of the base, that is h height is equal to 2r. So now what we are going to do is, first you have this volume of the cylinder. So what is the volume of the cylinder? V is equal to pi r square h. Now we have to express one variable in terms of other, because you have been given a surface, I mean the total surface area of the cone. இப்போ அந்த டோட்டல் சர்ஃபேஸ் ஏரியாவில் ஃபிக்ஸ் பண்ணிக்கிட்டு நீ மாடிஃபை பண்ணிக்கலாம், கோனோட ஹைட்டு ரேடியஸ்லாம் மாற்றிக்கலாம், பட் ஏரியா மட்டும் மாற்ற முடியாது. அப்போ என்ன ட்ரை பண்ணோன்னா, we are trying to maximize the volume. So what is the relation between height and radius? This is the relation. Your height becomes equal to the diameter of the cylinder. அந்த நேரத்தில் தான் the volume is maximum காமிக்க போகிறோம். So அதுக்கு we have to get rid of one of the variables in terms of the other. As usual நம்ம என்ன பண்ண போகிறோம், இங்கே நம்ம ஹெச்சை ஒழிக்க ட்ரை பண்ணலாம். Instead of eliminating r, it's better you eliminate this h. அப்போ என்ன பண்ண போகிறோம், 2 pi r h plus 2 pi r square is equal to k. அப்போ அதிலேருந்து 2 pi r h is going to be k minus 2 pi r square, and therefore your height is equal to k minus 2 pi r square by 2 pi r. So வழக்கம் போல we have formulated a function and then to eliminate one variable in terms of the other. எல்லா சம்லையும் நடக்குது நமக்கு. So இப்போ next we are going to have the volume. So volume when you make this substitution, what do you get? V equal to pi r square into this k minus 2 pi r square by 2 pi r. So you can cancel this pi, you can cancel one of this r. So what you get back is just simply this 1 by 2 is to stay there, k into r minus 2 pi r cube. அவ்வளோதான், வழக்கம் போல் we have got a function exclusively in terms of a single variable r. So now your volume is maximum, your v is maximum if your v dash, the derivative is 0, and at the same time your second derivative is negative. So this is a condition for a function to attain a maximum. அதை mention பண்ணிடுங்க. So now we know what you are going to do. We are just going to differentiate v once now and then again. So first v dash, if you don't want to write dv dash, you can even write dv by dr, both are same. So what is it? K, r with respect to r you get 1, and this is 2 pi r cube is 3r square by 2. So you have to simplify this, because this will be given your correction key like this. So it's better you write always a simplified version, and then you can also find v double dash here itself. So now k is constant, so 0 minus, when you differentiate r squared, comes down as 2r, so 12 pi r into r with respect to r is 1 by 2. So finally your v double dash is just minus 6 pi into r. So your second derivative is ready. So now what you have to do is equate your first derivative to 0 and find that critical value, that is the value of r. So equate your v dash equal to 0. What do you get then? K minus 6 pi r square by 2 equal to 0. So from that we need to track down this r. K minus 6 pi r square 0, therefore 6 pi r square equal to k, r is equal to, r square is equal to k by 6 pi. If you want r, you can write it. You are going to take the positive square root. Being radius, it cannot be negative, so you no need to have a plus or minus there. So r is positive. So this itself ensures that your second derivative is positive, but still we have to make a claim regarding this. So when r is equal to this, that is your r square or your k is equal to, both are same, writing this is same as writing k equal to 6 pi r square, both are same. From this we have got it. So your second derivative, namely v double dash, is minus 6 pi into root of k by 6 pi. So that is minus root of 6 pi into k, which is negative, and this ensures that v is maximum if your relation r k is equal to this. You can write either this or that, both are same. So now what we have to show is a height is equal to the diameter, that is h is equal to 2r. So now that we have got this relation of k is equal to, so what we have got is v is maximum if your k is equal to 6 pi r square, that is, in other terms, r is equal to square root of 6 by k by 6 pi. So now make a substitution of this. We don't require the maximum volume, he is asking us the height. So height is equal to k minus 2 pi r square by 2 pi r is what we have already. So let's make a substitution here for k. That gets you 6 pi r square minus 2 pi r square by 2 pi r. So what you get finally is 4 pi r square by 2 pi r, and therefore obviously finally you have 2r. So h is equal to 2r. So we have proved that the height is equal to the diameter. So whenever you have a given fixed surface area of a cylinder, you can maximize the volume of the cylinder. In that situation, your height becomes equal to the diameter. So these are all interesting results, and there is no dimension, nothing is fixed, everything is in general. So all these you can take as a general result, like a theorem. These cannot be changed for any h or any r, and for the same matters any surface area. You can take any fixed surface area and you start finding the maximum volume. Finally you'll end up with your height being equal to the diameter. So if you want to construct a cylindrical tank of maximum volume with a given material, say some tin sheet or plastic material, you can maximize the volume when you have the dimension of the cylinder as a height equal to the diameter of the base. Only then your volume will be maximum, otherwise you will be wasting that material. Okay, so this is what it's evident from this result.